Hi everyone, in this video we will discuss KNN algorithm which stands for K nearest neighbor algorithm. Let's quickly go to the agenda of this video. We will start with what is KNN, then we will see some applications of it, then we will discuss how KNN works and we will see some pros and cons of KNN algorithm. And finally, we will end this session with an interesting use case, Spotify songs hit or flop predictor using Excel. What is KNN? KNN is a simple algorithm that stores all the available cases and classifies the new data or case based on a similarity measure. It assumes the similarity between the new case or data and available cases and put the new case into the category that is most similar to the available categories. KNN algorithm stores all the available data and classifies a new data point based on the similarity. This means when new data appears, then it can be easily classified into a well-suited category. KNN algorithm can be used for regression as well as for classification, but mostly it is used for classification problems. It is also called a lazy learner algorithm because it does not learn from the training set immediately. Instead, it stores the data set and at the time of classification, it performs an action on the data set. Applications of KNN. The following are some of the areas in which KNN can be applied successfully. Banking system. KNN can be used in the banking system to predict whether an individual is fit for loan approval. Calculating credit ratings. KNN algorithms can be used to find an individual credit rating by comparing with the persons having similar traits. Politics. With the help of KNN algorithms, we can classify a potential voter into various classes like will vote, will not vote, will vote to party Congress, will vote to party BJP. Other areas in which KNN algorithm can be used are speech recognition, handwriting detection, image recognition, and video recognition. What is K in KNN? Well, this K determines how many neighbors need to be consulted in order to make a decision. For instance, if we consider k equals to 1, then test points are given the same label as the closest one in the training set. If k equals to 3, the labels of the 3 closest data points are checked and the most common label is assigned to the testing data point. In this case, most common label is red, so testing data point assigned to red. Let's say k equals to 5 and a new data point is classified by the majority of votes from its 5 neighbors. In this case, most common label is yellow, so testing data point assigned to yellow. How KNN works? KNN uses feature similarity to predict the values of new data points. The main logic behind KNN is when a new data point appears, this new data point will be assigned a value based on how closely it matches the points in the training set. Let's understand this concept with an example. Suppose we have a dataset which can be plotted as follows and we are taking the value of k equals to 3. As you can see in the plot, we have some red data points and green data points. Now we have a new data point and we need to classify this new data point either into red class or green class. Now, let's recap the logic behind KNN. It says that when a new data point appears, this new data point will be assigned a value based on how closely it matches the points in the training set. By visually seeing the plot, we can say that this new data point belongs to red one. Now the question is, how can computer knows that this new data point is closer to the red one? Pause the video and think about it. The answer is, we need to calculate the distance between this new data point with the other data points. There are mainly two methods to calculate the distance. One is Euclidean distance, which is the straight line distance between two data points in a plane. Another one is Manhattan distance, the distance between 2 points measured along axes at right angles. In this example, we will measure with Euclidean distance. Now, we need to calculate the distances from the new data points. After calculating all the distances, as we take in the value of k equals to 3, we need to identify the top 3 points which are closer to this new data point. These are the points closer to the new data point. Now, based on the frequent class of these points, we need to assign the class. Among those 3, 2 of them lies in red class. Hence, the new data point will also assign to red class. In this way, KNN algorithm predict the class of a new test point. In this example, for demonstration purpose, we assume the value of k equals to 3. But in the real case, we need to choose the value of k because this k parameter affect the accuracy of the model. So, how to choose the value of k? Pause the video and try to think about it. K in KNN algorithm is based on feature similarity. Choosing the right value of k is a process called parameter tuning and is important for the better accuracy. Finding the value of k is not easy. Few ideas on picking a value for k. There is no structured method to find the best value for k. We need to find out with various values by trial and error and assuming that training data is unknown. Choosing smaller values for k can be noisy and will have a higher influence on the result. Larger values of k will have smoother decision boundaries, which mean lower variance but increased bias, also computationally expensive. Another way to choose k is through cross-validation. Take the small portion from the training dataset and call it a validation dataset, and then use the same to evaluate different possible values of k. In general practice, choosing the value of k is k equals to square root of n, where n stands for the number of samples in your training dataset. Try and keep the value of k odd in order to avoid confusion between two classes of data. Pros and cons. Pros of KNN: simple to implement, flexible to feature or distance choices, naturally handles multi-class cases, can do well in practice with enough representative data. Cons of KNN: need to determine the value of parameter k. Computation cost is quite high because we need to compute the distance of each query instance to all training samples. Use case: Spotify songs hit or flop predictor. As you can see, we have a dataset which consists of some of the Spotify songs like Lucky Man, On the Hotline, etc. And we have artist column, some of the features like speechiness, liveness, tempo, etc. We can't predict a song whether it is hit or flop based on these few features. There are around another 15 features present in this dataset, but I removed those features and kept only 3 for easy calculation. In the target column, we have some ones and zeros. Here, 1 indicate it is a hit song and 0 indicate it is a flop song. Now, we have a new song F You Right Back. For this song, based on the above training set, we need to predict whether it is a hit song or a flop song. We will predict it using Excel, and in the next video, we will implement this problem in Python. So, don't forget to subscribe the channel for future updates. As we discussed above, there are 2 things we need to consider while solving the problem. What is the value of k? Which method we need to use to calculate the distance? To find the value of k, we will use the k equals to square root of n formula, where n stands for the number of samples in the training set. For this problem, we have 11 samples. So the value of k will be 3.31, which is around the value 3. So we will take k equals to 3. To measure the distance, we will use Euclidean distance. There are mainly 3 features in the dataset. We are not considering artists and track as features. Using the Euclidean distance formula, we need to calculate the distance from the testing data point. Now, we calculated all the distances. We need to identify top 3 points closer to the testing point. Since majority of points belong to the flop category, our testing data point will also belong to the flop category. That's it. If you like this video, please do like, share, comment and subscribe to our channel.